Section 1.2, today we're going to define geometric terms. Our first definition is space. Space is the set of all points. We'll discuss space a lot as being the entire classroom. If you can imagine points on the walls and the ceiling, the floor filling up the classroom, all of those points comprise space. The next three definitions are what we call undefined terms. The first one is a point. A point has no dimension, and it's named with a capital printed letter. And we have a symbol that represents a point, but as small as I draw that point, there's always one that we can draw that's smaller. So this is how we represent a point. And a point is named with a capital printed letter. So there's point A, point B, point C. And it's very important that you use capital printed letters when representing points. Our second undefined term is a line. A line extends in only one dimension. It's named by a lowercase script letter or by 2 points contained on the line. So we're going to draw a line. We want to be sure that we put the arrows on the end of the line, because lines keep going, they never end. And remember, a line is just a lot of points strung together. Okay, so we have points on our line, so maybe this is our point A, point B, C, D. And there are two different ways we can name lines. The first one is a lowercase script letter. Script is like a cursive letter, and usually we use L, M, N, P, that part of the alphabet. So you could say that this is line L, and just using the L, the fact that it's lowercase and script would tell the person looking at it that it's a line. The other way you can name a line is by using a symbol and 2 points contained on the line. And because a line is made up of all of these points, we want to make sure we're only using 2. The symbol for a line will go above the letters, and it looks like a little line. It must have the arrows on it. So you could call this line AC, or line AB, BC, CB, any 2 letters in any order. And those must be capital printed letters because they're points. The third undefined term is a plane. A plane extends in 2 dimensions, and it's named with a capital script letter or with 3 points that are contained in the plane, and we'll talk about that. So we're going to go to the next slide, actually, and draw a plane. A plane extends in 2 dimensions, so it not only has length like a line, but it also has width. A plane is never ending. It's about as thick as a piece of paper, but it's rigid and you cannot bend it. So if you could hold a piece of paper and imagine that it goes up and down and left and right infinitely. It keeps on going forever. Again, it's about that thick and you cannot bend a plane. Because it never ends, when we draw a plane, we usually represent it with a parallelogram. And again, there are lots of points. So there's our A, B, on the plane. There can be lines in the plane, that's okay. And sometimes in a plane, there's a capital script letter in the corner, kind of a capital cursive letter. So if we go back and look, these are named with either the capital script letter, and you won't create that. It must be already in the picture on the plane to use it, or with 3 of the points contained in the plane. So we could say this is plane R. And again, you don't actually have to write the word plane because the fact that it's a capital script letter will let the person looking at it know that it's a plane. Or you could use the 3 letters. We could say it's plane and any 3 letters. Now, I have 4 on here, but again, we only want to use 3. So I'm going to say it's plane BCB. Someone else might have called it plane ABC or ADB. Any 3 letters, and again, those are representing points. They must be capital printed letters. A couple other definitions just to kind of lay the groundwork for the rest of the trimester. We have collinear points. And if we look at the word collinear, the prefix co means together or same. And then linear, we talked a lot in algebra about linear equations and linear graphs. That means line. So this literally means the same line. So these are points that lie on the same line. The next one is coplanar, same prefix. Co means together or the same. Planar. So these are points that lie on the same plane. So if we went back to our picture of the plane, those 4 points, A, B, C, D, are coplanar points. Some of those that we could draw a line through, if I can draw one straight line through them, those would be collinear points. They're on that same line. We have a couple other figures we're going to discuss. The first is a line segment, and we usually just call it a segment. This consists of 2 endpoints and all of the points between those endpoints. It's part of a line. It's like a section of a line. So 2 endpoints. Here's a beginning, here's an end. And all the points between there. So they make up part of a line. And these endpoints, since they are points, will have capital printed letters. To name a segment, you're going to use those 2 endpoints, the beginning and the end of the segment you're talking about. And the figure you're going to put above it is like a little segment with no arrows. You don't have to worry about the dots, just leave the arrows off. So this is segment EF, or you could call it segment FE. And make sure as we go, pause and write down these definitions. These need to be part of your notes. The next word is ray. A ray consists of an initial point A and all the points on the same side of A as B. So let's go draw a picture. So we have this point A, we have this point B. So a ray starts with the initial point, that's its beginning point A, and all the points on the same side of A as B. Now when we name a ray, it says it's named by the initial point and any other point on the ray, but the initial point must come first. So we are going to use A first. Any other point, we could use B. If there was a C over here, maybe we used AC. And the symbol for the ray looks like the ray. It has an arrow on one end. Now, we always put this initial point first. So if the ray was drawn this way, let's say this is D and here's C. Because the initial point, the starting point must come first, we would put D, C. Be aware that these are not always alphabetical. So for a ray, the initial point has to come first and then a point closer to the arrow. We also have what are called opposite rays. These are 2 rays that share an initial point and continue in opposite directions. So here's that initial point that was A, and here's B. And I'm going to draw another ray that starts at A and goes in the opposite direction. Let's just say this is C. And if you notice, those opposite rays form a straight line. The next word is intersect. 2 or more figures that share 1 or more points, they could share a line that's more points, are said to intersect. The set of points that they have in common is their intersection. And be sure you pause and write down the definitions. We're going to work through some examples. This first example, we need to draw a cube. And drawing a cube is very easy. I'm just going to trace the cube that's already here to show you. To draw a cube, you first want to draw a square. We'll worry about the letters in a minute. So draw a square. You're going to draw an additional square that's offset. You want it to be the same shape and size, but just kind of down and to the right a little bit. And then you're connecting the corners. Upper left corners, lower left, upper right, lower right. And we're going to name these on the top back from left to right is A, B, coming around clockwise C, D, and then same thing on the bottom. The back left is E, kind of the back right is F, front right is G, front left is H. And if you're having trouble with the cube, we can go back and talk about how to draw that during class. So we're going to work through a few examples. Number 1 says name 3 coplanar points. So we're going to use the box to talk about planes more. The box actually has 6 faces. It has a top and a bottom, a left and a right, a front and a back. And these can all be planes. If you picture the top of the box, kind of like a piece of paper on top of it, it's flat. And even though it looks like it stops, we're going to imagine that that top of the box keeps on going left and right, forward and backward infinitely. It keeps going forever. So we're going to use this to represent a plane. This will help you kind of put a concrete idea with that abstract vocabulary word. So we're going to name 3 coplanar points. So if you picture a box and think about a piece of paper, a flat, rigid piece of paper that you cannot bend. 3 coplanar points will be on the same plane. So you would be able to lay the piece of paper down and touch 3 points all at once without having the paper bend. So if I look at the box, I can see the top of the box has A, B, C, and D, and that represents a plane. So any 3 of those points would be coplanar. So I could say A, B, D. You could do the bottom of the box, E, H, F, any 3 of those. The left side, A, E, H, leaving D out. The right side, B, C, G, leaving out F. Any 3 of those that are on the same side. So then number 2 says name 4 non-coplanar points. That just means they're not on the same plane. So I want 4 points that if I laid my flat, rigid, unbendable piece of paper down, I couldn't touch all 4 points at the same time. And the trick to this is to choose 3 of our coplanar points, 3 points that are on the same side, and then 1 that's on the opposite side. So if we use the ABD, ABD was on the top of the box, A, B, D. And then I'm going to pick one from the bottom, H. Or I could do A, B, D, E or A, B, D, G. There's no way I could take one thin, rigid, unbendable piece of paper and touch A, B, D, and H all at the same time. It's not possible. So those are non-coplanar points. Number 3 asks you to name a plane. This is just like coplanar points. We can name our plane using any 3 points on that plane. So any 3 points that make up the side of a box. So I could do the back of the box and do A, B, and E. So plane A, capital printed letters. These are representing points, A, B, E. This would be the plane that's the back of the box. And we'll discuss in class some planes that may be more difficult to see on the box. Example 2, I'm going to have you draw these points in the same order as I do and answer a few questions to bring in with you for us to discuss in class. Example 2 says draw 4 non-collinear, so not in a straight line, not on the same line, points A, B, C, and D. So we're going to draw point A, capital printed letter because it's a point, B, I'm going to C over here, so they're non-collinear, right? They're not all 4 in a straight line. Now I'm going to write down some figures for you to draw using what we've talked about in the notes. I'd like for you to take A, B, C, D in this order, and on this one picture, draw all of these figures. So this is the first one. I pay really close attention to that figure above the line, whether or not it has arrows or no arrows on it. Okay, so these 4, you're going to have all 4 on this one picture using the symbols above. Bring that in with you to class tomorrow. Remember, if the slide changes too fast, you can always go back and you can pause. Example 3, sketch 2 planes that do not intersect and a line that intersects each plane in a point. To represent the planes, we're going to use those parallelograms. So it says sketch 2 planes that do not intersect. They do not share any points. So I'm going to sketch one plane. I'm just going to draw a parallelogram. Remember, the plane doesn't really stop here. It keeps on going left and right, up and down forever. It's infinite. This is what we use to represent it. So we have a concrete symbol. So here's my first plane. We need a second plane that does not intersect that. Things that do not intersect are parallel. So I'm going to draw my second one below this. So picture that one is above the other and they're parallel, stacked on top of each other but spaced apart. Now we need a line that intersects each plane at a point. So the line wouldn't lay on top of the plane. It can only touch it in one point. So what my line is going to do, it's going to come down through the plane. And there's a section that's underneath that we can't see. So we make that dotted. And then it comes out, touches this plane at exactly one point. Again, there's a little section we won't be able to see. And it comes out the bottom. So our two planes are parallel. They do not intersect. And the line intersects each plane in one point. Okay, the homework we'll be working on, and you can start the homework. We will work on this in class. There's a few types of planes in the boxes that we need to discuss before we move too far into the homework. We'll be on page 13 through 15. We're going to do 9 through 51, and that is all 55 to 63. And these problems are pretty short. A lot of them are, here's a picture, name two coplanar points, name two collinear points. So we will work on those during class